Hello everyone. So today I'm going to discuss about the practical, and the aim of the experiment or the practical is to determine the refractive index of a liquid by plane mirror and a convex lens. So the apparatus required for this experiment are a plane mirror, convex lens, water or any kind of liquid, and a scale or a ruler. Now let's see the theoretical background of this experiment. So for this experiment you need a clamp so that you can fix the optical needle with this clamp, and initially the convex lens is placed on the plane mirror, and you have to find out the focal length of this convex mirror. So after that you have to place a few drops of water in between this convex lens and the plane mirror so that it will form a plano-concave liquid lens, and then you have to again find out the focal length of this convex lens and this liquid lens combinations, and from these two focal length you can definitely find out the refractive index of the liquid which is in between this plane mirror and the convex lens. But before that, one thing you again need to find out, and that is called the the radius of curvature of this convex lens, and that can be easily found out by a spherometer. So after finding out the radius of curvature of the convex lens, so you have to put that value in this relation to find out the refractive index of the liquid. Now here f2 is the focal length of the liquid lens, which can be found out from these relations. So where f2 is the focal length of the liquid lens, and f, that is capital F, is the focal length of the lens, and that is convex lens and the liquid plano-concave liquid lens combinations, and f1 is the focal length of the convex lens. So once you find out the focal length of the liquid lens, so you have to put it here in this relations to find out the refractive index of the liquid. So the theoretical background of this experiment is very simple, and so let's go to the laboratory to find out the refractive index of the liquid. So this is the experimental setup. This is the clamp holder to fix the needle. This is the plane mirror. This is a convex lens, and this is a spherometer to find out the radius of curvature of the convex lens. So you have to find out the radius of curvature of this convex lens by this spherometer. Now initially you have to place the plane mirror on this platform. Then you have to place again the convex lens on this plane mirror, and you have to lower down this needle to fix the point of the needle at the center of this convex lens. So let's check whether it is in the center of the convex lens or not. So if the platform is not horizontal, or if the clamp holder is not vertical, then it will be difficult for us to maintain the axis of the needle. So when you keep this needle upward and downward, then you will find a inverted image of this needle, and so the inverted image will be like that, and you have to fix at that point. You have to fix the needle at that point, and simultaneously you have to measure the distance of the needle from the top surface of the convex lens. So you can do that by a thread or by a ruler or a scale. So you have to measure the distance of the point of the needle to the top surface of the convex lens by this ruler. So let's measure. So once you measure the distance, then you have to take out this convex lens, and then you have to measure again the needle distance between the needle and the plane mirror, surface of the plane mirror, and you have to note down simultaneously. And after that, you have to put some drops of water on the plane mirror. Should be very careful. So you have to place some like this, a drop of water on the plane mirror. Then you have to place the convex lens on the drop of the water, so that it will form a plano concave lens by the liquid or the water. Then again you have to repeat the same like the previous case. Then you have to find out the image formed by these combinations, that means lens and the plano concave liquid lens combinations. So you have to view through the top of this plug holder. Then once you get the inverted image of this object, that is for this case it is the needle, then you have to fix the needle at that point. Okay, so this is the point where we have seen the inverted image of this needle formed by this plano concave liquid lens and the convex lens, and simultaneously you have to measure again the distance of this needle between the distance between the needle and the top surface of this convex lens. So you should be very careful that there should not be any parallax error. So once then you have to take out this lens, and again you have to find out the distance between this needle and the surface of the plane mirror, and you have to note down this value in your practical logbook. Now let's come to the results and discussion part of this experiment. So first, as I have discussed before, that first you have to find out the radius of curvature of the convex lens by sperometer. Then you have to determine the focal length of the convex lens, and this is the table to find out the convex lens focal length. So as we have discussed in the experimental procedure of this experiment, so first you have to find out the height of the pin, that is height of the needle P1, from the upper surface of the lens H1, and from the mirror Then from these two value you can find out the focal length of the convex lens by these relations, and simultaneously you have to take 3-4 data by repeating the same procedure, and after that you have to find out the mean of these values. So that will give you the overall focal length of the convex lens. So the next step, as I have discussed, so once you have to place the liquid in between the plane mirror and the convex lens, and this is the table to find out the focal length of the combined lens. That is the focal length of the lens, that is convex lens, and the plano-concave liquid lens. So again, this H1 is the height of the pin P2 from the upper surface of the lens, and H2 dash or slash is the height of the pin P2 from the upper surface of the mirror. So again, you can find out the focal length of these combinations by these relations, and again you have to take 3 to 5 data by repeating the same procedure, and then you have to find out the mean of the focal length of these lens combinations, and that will give you the overall focal length of the combined lens. So after that you just need to put this value in this relations to find out the refractive index of the liquid. So during the experiment you should take some precautions so that the error could be minimized. The precautions for these experiments are to find the coincidence of the object pin with its real inverted image. Parallax should be carefully avoided. So parallax error should be, you should try to reduce the parallax error, otherwise you will get a wrong refractive index of that liquid. The second is the pin should be moved along the axis of the lens, and the third one is to avoid the backlash error, the speedometer screw should be rotated in the same direction, and the speedometer screw is lowered down until the tip of the screw just touches the tip of its own image below the surface.